Okay, our objective today is to review function notation and to talk about a new concept called linear combinations. So let's start with the warm-up here. If you didn't finish it, please do it as we're going over it. So number 1 and 2, you need to evaluate the function when x equals -2. Someone explain so I can make sure you know what you're doing. How do you do number 1? Travis. Good. So we're evaluating the function when x is -2. So we have 1/2 times -2 plus 3. After you evaluate that, what do you get? So what'd you get for your answer here? Dirk, what'd you get? Good job. So f of -2 equals 2. You need to write your answer as an ordered pair. Your ordered pair should be -2, comma 2. Do you remember from the video yesterday, f of x is equal to what? Good, thank you. F of x is equal to y. It's just notation. You know, people that discovered math or came up with this many years ago just decided that this would be good notation to use when you're evaluating a function for something. So f of x is always y. Keep that in mind. So number 1, you should have -2, comma 2. All right, Matt, what did you get for your ordered pair for number 2? Good, -2, comma 6. All right, number 3 and 4, a little different. They now give you f of x equals -3. Haley L., where do we put that? Good. So hopefully you remember on the video yesterday, I told you to cross that off or scratch that out. The reason I would like you to do that is because last year and the year before, so many people would put that in the wrong spot. So if you scratch off f of x, you are replacing this whole thing with -3. So scratch it off, replace it, solve for x. All right, Amanda, what did you get for number 3? You didn't do that one? Reno, number 3. Okay, Haley L., number 3. No? Heather, number 3. Good, -15, comma -3. Mumta, number 4. Okay, I want everyone to do number 4. You guys need to make sure you're trying the warm-up. A lot of you didn't do it. So try number 4. I want you to evaluate when f of x equals -3. And I want all of you to have your answer as an ordered pair on your paper, please. So write your answer as an ordered pair on your paper. Good. Because if this is disastrous, then I need to do more examples with you. Wait, actually, you have them backwards. 3, -3. Because -3 is y. Okay. FYI. Good job. Good. Good job. You have them backwards. Remember, x is 3. You know what I mean? So it should be x, comma, y. Make sure your ordered pair is always x, comma, y. Try that again. You're given, and this needs to stay x. Because you're given what y is, you know what I mean? So look for x. That's not right either. This -3 is y. So the whole f of x goes away. Do you see how I scratched it off there? Scratch it off. Plug in for that f of x. All right, so the first thing that you all should have done, I think some of you guys are sleeping on me here, -3 is going in for f of x. That whole f of x is gone. So you have -3 equals -4x plus 9. And then you're solving a 2-step equation. Subtract 9 on both sides. You have -12 equals -4x. Divide both sides by -4. You get x is +3. So your answer for number 4 is 3, -3. Okay, any questions? Because you need to ask. I can't read all your minds here. 1 or 2 or 3 or 4. 2 different types here. Okay, let's go over homework. I'm going to quickly go around the room. I want you to tell me what you got as an ordered pair so I can make sure that you guys are okay before we move on to the lesson today. Okay, homework was 4.7. And you guys had 1 through 22, but you had to evaluate 2 different things for 1 through 12. Let's start, Mom, we'll start with you on number 1. Can you tell me the 2 ordered pairs that you got? Good job. Sage, number 2. Okay. And? Good job. Good job. Garrett, number 3. Okay. Haley Waters, number 3. Good. Good job. Amanda, number 4. You forgot about the other one. You need the -3 one first. Do you have the -3 one on there? No? Okay. So the 2, I'll just put them in this order. 6.5 is correct. The -3 should be -9.75. So you need to make sure you have both of those. Okay? You did? Oh. Reno, number 5. Good job. Jake, number 6. Okay, Maggie, number 6. Okay. Good job. Matt, number 7. Two, what did you get for the 2? You said, good. -0.4, or if you had, -2/5, that's fine. Thank you, Matt. Number 8, Dirk. Okay. Good job. If you have 2/3 for that one, that is fine. Will, number 9. Oh, go ahead. Yes, it should be. Thank you. I'm just trying to do too many things at once. Thank you, Will. Okay, number 9, you could either have fractions here or decimals. Jackie, number 9. 7.125. Okay. Good job. And if you have the fractions here, the first one is -57/8. The second one is -21/4. Melissa, number 10. 2, you said? Good. Awesome. Haley L, number 11. Okay, this is right, but the -3 is not. Did you say 5.5 for the -3? What did you say? Okay. Travis, what did you get for the -3? Good job. Helene, number 12. Okay. Good job. Okay, before I move to the next part, any questions on 1 through 12 or anything? I might have made a mistake. Anything you need me to reread? Okay. I'm going to read through the answers of most of the next ones. So let's go over 13 through 22. Okay, Alan, what did you get for 13? Good. So 5, 18, please make sure you have it as an ordered pair. Mamta, number 14. Good. 5, 39. 15 should be -3, 21. 16 should be -2, 14. 17 should be 4, 23. 18 should be 5, 30. 19 should be -3, 3. 20 should be 10, 82. 21 should be -5, 18. And 22 should be 10 and 31.9. All right, any questions on any of the homework? Positive? Okay, thumbs up, thumbs middle, thumbs down on function notation, so I know where you guys are with this. Thumbs up, thumbs middle, thumbs down. Those of you that are sleeping. Okay, thank you. All right, if you guys are good, notes to page 16, please. Okay, so in the last part of class here, I want to introduce to you what a linear combination is. This is one of those lessons I think that you just need some common sense for, which you all have, so it's really not that bad, but it's something that we need to teach. So if you see this on an exam, you know what the directions mean if they say find a linear combination. So the objective is to determine if a linear pair is a solution to a linear equation. Does anyone know what a linear combination is? Has anyone heard of it? You did learn them in pre-algebra in chapter 8, but it was just for a short amount of time. Okay. All right, so we're on page 16. At the very top, it says linear combinations. Okay, so let's start with the definition here. So a linear combination is an ordered pair that is a solution to a given equation. So we spent a lot of time this year, talking about linear functions, the point-slope form, standard form, slope-intercept form. You guys have done a lot of practice with getting them into those forms. The function notation that you did yesterday, you came up with an answer. The answer that you got is a linear combination of that function, which means it is a solution to that equation. You can take that x and that y value, plug it back into the equation, and it should be true. If you did it correctly, to check your answer, if you plug them back in, it's a true statement, which means you did it correctly. And I'll show you that today. So here's what I basically just said. The ordered pair x, y, and then there's a line for you to fill in. The coordinate falls on the graphed line of the equation. So we were going to show you this, but it's not necessary. I'm just going to explain it right now without showing you. Basically, if you have a graph, all that's saying is every point on the line of that graph is a solution of the equation. So again, every point on the line is going to be a solution to that equation. So let's say that my equation is y equals 2x plus 3. If this is the line that goes with this function, every single point on here, let's say I chose 2, 3. If we plugged it into this equation, if that was correct point that I chose from there, then it would be a solution or a linear combination to that function. So that's what we're going to do today, but we're actually going to do it where if you're given the equation, they're going to give us an ordered pair. And you can still do this with function notation, but we're not going to. Okay, so here's the first example. And I have a little graph here, which I'll graph in a second, but let's actually do the problem first. So it says here, is 2, 7 a solution to the equation y equals 2x plus 3? So it tells us here we need to substitute the x coordinate in for x, and we need to substitute the y coordinate in for y. The very first thing I want you to do is put an x and put a y underneath your ordered pair. Very first thing I want you to do is put an x, put a y underneath the ordered pair. Is everyone with me? Okay, all we're going to do now is plug in the x and the y into this equation and determine if this is true or not. It's that easy. So we have y equals, I'm going to rewrite it here, 2x plus 3. The y is 7, so plug 7 in for y. 2 is x, so plug 2 in for x. So all we did was take the y, plug it in for y, take the x, plug it in for x. Like yesterday, using order of operations, let's simplify. 2 times 2 is 4. Rewrite your plus 3. 4 plus 3 is 7. So does 7 equal 7? Yeah. So I'm going to put a check mark. Basically, your answer here is yes, 2, 7 is a linear combination of y equals 2x plus 3. Which means if we graph that, that is a point on the line of the equation. So let's graph it. I want you to sketch a graph. I have it on my notes. If you look at mine, sketch a graph next to that problem. There's some room on the side. just by hand. Just want to talk through a couple things before we try a couple more examples. And yes, I know yours is going to be an estimate. So when we graph this, Jake, where do we start? Good, 0, 3. So 0, 3, go up on the y-axis to 3, put a point. Will, what do we do next? Good, go up 2 to the right 1, up 2 to the right 1. So you get the opposite point, down 2 to the left 1, down 2 to the left 1. And I'm actually going to go up one more time here. Connect your points, not like mine, they should be a little bit neater. So let's look at this graph for a second. Is the point 2, 7 up there? Do you see 2, 7, which is what we just plugged in? Look at the graph on the smartboard. Is 2, 7 up there? Just give me a head nod this way or this way since you guys don't feel like answering. Okay, it is. 2, 7 over 2 up 7 is right here. This point is a linear combination of this equation because it falls on the graph. Every single point on this graph, on this line, is a solution to this equation. So is there going to be more than one linear combination for that? Yes. One other way you could do that is if you graph this on your calculator. Do you remember from last year hitting the table button on your calculator? We're not going to do that, but that shows you a ton of linear combinations. So that's another way to check. I know a lot of your teachers did that last year. All right, any questions on that? All right, one more question I have for you. How would you write this ordered pair in function notation? So how would we write that ordered pair in function notation? Anyone know? Remember, the x is 2. You could do f of 2, and then your y is 7. So just one way to write that is f of 2 equals 7. Remember from yesterday? Your x goes in parentheses. F of x is what y is equal to. You don't need to know that. I just wanted to go over that. Okay, let's do another one. Okay, example 1. We're going to do one more together here. Is negative 3, 4 a linear combination for y equals negative 3x minus 5? So let's check. Very first thing I want you to do is write down underneath the ordered pair what is x, what is y. Plug them in. Let's see if it's true or not. So we have y equals negative 3x minus 5. Plug 4 in for y. Plug negative 3 in, if I can write, for x. And let's simplify and see. We have 4 equals negative 3 times negative 3 is positive 9. 9 minus 5 is 4. So you should ask yourself, does 4 equal 4? Yeah. So yes, this is a linear combination. And again, all that means is that is an ordered pair that falls on the graph. So that equation that's going to be on your graph, it falls on that. There are many different linear combinations for every equation. Okay, I want you to try 2, 3, and 4. Actually, sorry, just 2 and 3. So just try 2 and 3. Be careful with the fractions. Is this easier than yesterday's lesson? Okay. Try this one again. Oh, you wrote the fraction wrong, that's why. It should be 1/4, not 1/2. All right, John, number 2, yes or no? Say that again. Good. Why was it no? Good. This one is no because 8 does not equal 13. Does anyone need me to go over any part of that? Okay, number 3, Dirk, yes or no? Okay, why? Good. This one is yes because 6 equals 6. So let me just go over one part of that. When you plug in your x and y, what is 1/4 times 4? Jake? Good, 1. So that's how you end up with 6 equals 1 plus 5. 1 plus 5 is 6. If you're not sure of fractions or you don't like them, put that in your calculator in parentheses and hit times 4. Okay, let's do number 4 together. And I think we're going to be done after this. So 5 comma negative 3, does that fall on this line? So we have negative 3 is y. So if you didn't already do this one, plug in negative 3 equals negative 2/5 times 5, which is x, plus 8. What is negative 2/5 times 5? Either on your calculator or mentally. What's negative 2/5 times 5? Will? Good, negative 2. So we have negative 3 equals negative 2 plus 8. Again, if you're not sure, use your calculator, put that in parentheses, and hit times 5. What's negative 2 plus 8? You guys should all know this. You guys are really tired today. 6. So you're asking yourself, does negative 3 equal 6? No, it does not. So no, this is not a linear combination because it does not fall on the graph, or in other words, on the line. Any questions? Easy? All right, I need you to open up your homework packet to page 33. I promise this won't take you long. So open up to page 33. I'm going to explain a couple things. Okay, I just want you to do numbers 1 through 8. Okay, but I need to explain something. So you should be able to fit this, but if you write big, feel free to use a notebook or another piece of paper. What I need you to do, so this is easy for us to go over on Monday, do you see how for each one there's 2 ordered pairs? I want you to label the first ordered pair A and the second ordered pair B. So what Ms. Wingrove and I did is when we showed our work, I have an A, we have an A and a B underneath each number. If it's yes, I put a check mark. If it's no, I put an X. You can just put yes or no. Show your work. So I'll say that one more time. For number 1, and for all of them, label the first ordered pair A, the second one B. So the first ordered pair A, second ordered pair B, that goes for all of them. So you're doing an A and a B for each one. Your answer for each of them is going to be yes or no. Please show your work. 7 and 8 do not use X and Y. So for number 7, the S is the X, the T is the Y. Whatever comes first closer to A in the alphabet is always X. For number 8, A is X, B is Y. I don't know why they do that. Got it? Okay, you have, 12 minutes or so. You have plenty of time. I will walk around in case something is confusing to you, but please do A and B for each of them. If you're still unsure of something with function notation, let me know, because Tuesday's your quiz, so we're going to start reviewing Monday. Well, I'm coming. Yeah, definitely. Yes, or keep everything on here. It's fine with me. And again, make sure you're plugging them in. Show your work, which is just plugging them in. If it's true, it's yes. If it's not, it's no. You got to do your answer, though. Oh, gotcha. Sorry, Amanda. You got it. Oh, S, this is the X, and the T is the Y. This is X, and this is Y. Now you can cross simplify if you want, or multiply across the top, across the bottom, and then divide it. It's up to you. Yeah. If you need anything checked, let me know.